All right, now that we have been able to solve some polynomial equations, what we're going to do is we're going to jump ahead and we're going to start looking at polynomial inequalities. Now we're jumping a couple sections because the next topic is going to be getting into some rational functions. And I thought that before we get into the rational functions, let's finish up the polynomials with working with the inequalities as well. Along with this section is going to be working with rational inequalities, which we can get to after we talk about rational functions. So first of all, what are we doing when we are solving an inequality? You're looking at when something is going to be greater than or less than a particular value. And here with our polynomials, we're going to be looking for when is our polynomial greater than 0, when is it less than 0, perhaps greater than or equal to, less than or equal to. And up until now, we've been working with equations. And if I take this graph that I have over here to the left, where I see that I have 3 zeros, if I'm looking for the values of when f of x is equal to 0, I would see here that x would equal a, x would equal b, and x would also equal c. At those 3 points, that's where I have my x-intercepts. That's where my zeros are going to be. Now, what if I wanted to sit here and talk about, well, when is your function greater than 0? My function is going to be greater than 0 when we are above the x-axis. So here I have a portion of my graph that is above the x-axis. From A to B, I'm above the x-axis, and from here at point C, I'm above the x-axis. So there are actually 3 separate intervals right here that where our function is greater than 0. We have the values of x that are less than a. I have the values of x that are greater than a but less than b, so it's between that interval. And then lastly, we have the values of x that are going to be greater than c. When I talk about the values that are less than a, we're talking about the interval from negative infinity to a. When we talk about from a to b, we're going from the interval of a to b. And the values that are greater than c, we're talking about anything from c all the way to positive infinity. And that right there is when our function is going to be greater than 0. It's when it's above the x-axis. When I look at when our function here is going to be negative, it's going to be negative for when it is below the x-axis. So we are seeing that it is below the x-axis for when x is between the values of b and c. So our interval here would be looking at from b to c. Greater than 0, we are above the x-axis. Less than 0, we are below the x-axis. Now here I'm working with greater than rather than greater than or equal to, so I'm not going to actually include those values of a, b, and c because those would be when it's equal to. Okay, here's an example of a polynomial where I have it graphed out to the left where we can clearly see what our obvious zeros are. I have an obvious 0 here at -1. I have an obvious 0 at +1, and we have one here at 4. So here I'm looking at when is our function f of x equal to 0? Well, that's going to happen when x is equal to -1, when x equals +1, and when x is equal to +4. Now if I want to look to see, okay, when is our function going to be greater than 0? I'm going to look to see where am I above my x-axis. And I am above my x-axis in 2 separate points here. I am looking at being above the x-axis from the interval of -1 to 1. So I have when x is greater than -1 but less than +1. I also have the interval here from 4, which is going to be increasing, so when the values of x are greater than +4. If you wanted to use your interval notation, -1 to 1 and 4 to positive infinity. Looking at where our function is going to be less than 0, we're going to go below the x-axis, which points us into 2 directions right here. The first one that I've highlighted in yellow, we're talking about the values of x that are less than -1. And the purple is referring to the values of x that are going to be greater than +1 but less than 4. So our interval, we're going from -infinity to -1, and we're going from 1 to 4. So by just looking at your graph, you can determine whether it is positive or negative. Well, let's say that you don't have graphing capabilities in front of you. How can you figure out when it's going to be positive or negative? You can use what we call the polynomial sign chart. And the sign chart is going to help you determine when your graph is above or below the x-axis, because it's going to help you pinpoint some of your critical points here. Now, the one thing that you would need to be able to do in order to do a sign chart is you'd have to be able to factor it out or be given the factors so that you could identify where your zeros are. So here I've taken this third degree polynomial and I've taken it and I've factored it out into its factored terms. This right here is telling me that where I have -1, that is one of my zeros. At +1, I have a 0, and at +4, we have a 0. So that's where our graph would be crossing our x-axis. Now that leaves open 4 different intervals. We have from -infinity to -1, -1 to 1, 1 to 4, and 4 to infinity. Those are 4 intervals that either our graph is going to be positive or it's going to be negative. So what we're going to do is we're going to figure out, well, when is that going to happen? And we're going to make a little sign chart. So starting out with, I'm going to start over here to the left for when the values are less than -1. What I'm going to do here is I'm going to pick a number that is less than -1. For example, -2. I'm going to take -2 and I'm going to plug it into my factors. -2 plus 1 would give us -1. And so what I'm going to end up getting here is I'm going to be getting a negative answer for that factor. No matter what number I pick that's less than -1, anything less than -1 plus 1 is always going to give us a negative. Then if I look at, okay, x minus 1, if I take -1 and I subtract, if I take -2 and I subtract 1, I get -3. I'm going to get a negative number there no matter what I choose. Any number that's less than -1, subtract 1 from that, it's going to stay negative. And then the last part here, x minus 4, if I take a -2 minus 4, I get a -6. No matter what number I plug in here, I'm going to get a negative. So it doesn't matter what I do, I'm going to get a negative times a negative times a negative. And when I multiply all of those out, I'm going to end up with an overall negative answer. Moving to the next interval here, if I pick a number between -1 and 1, I'm going to pick a 0. 0 plus 1 is 1. That's going to give me a positive answer. Any number between -1 and 1 is going to give me a positive answer there. Next part, 0 minus 1 gives me -1. No matter what I pick here, I'm going to get a negative answer. 0 minus 4 is -4, and whatever I put in there, I'm going to get a negative answer. Well, now when I look at this, I've got x, or positive, times a negative, times a negative. Overall, right there, then, that's going to give us a positive once I multiply everything out. Okay, next interval from 1 to 4. I'm going to pick +2. 2 plus 1, so that gives me a positive number. 2 minus 1, well, that's going to give me a positive number. And 2 minus 4 would give me a negative number. When I take a positive times a negative, multiplying those together, I'm going to always end up with a negative. And then the last one here, greater than 4. So if I pick 5, 5 plus 1 gives us 6, that's positive. 5 minus 1 is 4, that's positive. And 5 minus 4 is 1, and that's positive. When I multiply 3 positive numbers together, I'm going to get a positive as well. So what this is helping me do here is it's telling me where my graph is going to be positive and where it's going to be negative. The fact that from where x is less than -1, it's going to be negative, I'm going to be below the x-axis. Here where I am between -1 and 1 and it's going to become positive, I'm going to be above the x-axis. From 1 to 4, I'm going to be below since it's negative, and then here for when x is greater than, I'm going to be positive. This is a general sketch of what our graph is going to be looking like. If I went to my graphing calculator and I plug in the function that I have here, so x to the third minus 4 x squared minus x plus 4, graph it out, you'll see that it kind of resembles the same thing here. We're starting negative, and then it's being positive, then it goes back to negative, and then it's increasing again. There's a couple other things that you can think about to help you with this problem, especially the fact of looking at what your leading coefficient is. Our leading coefficient here, and our leading term, is the 1x to the third. Our leading coefficient is 1, our exponent, our degree that we're working with, is 3. We've talked about, if you have a third degree polynomial, of what that end behavior looks like. If I were to zoom out on this image, I would be able to see that chair function showing through. And that's just saying that as the limit of x approaching positive infinity of our function here of f of x, you're going to have positive infinity. As x gets bigger, y is going to increase as well. On the other side of things here, if we take the limit as x approaches negative infinity of our function, now we're going to end up with a negative infinity. It's going to be decreasing at that point. Well, increasing, but it's going to be going down towards negative infinity. All right, so this is just the fact that I had it all factored out for us. We were able to do the sign chart to be able to kind of get a general idea of what the graph looks like. But you guys know that you've got your calculators to help you with that as well. Next, I wanted to show you what happens when you're dealing with some multiplicities that you're going to be working out, and trying to see what we do in a situation like this. So first of all, when you look at the problem here, you've got 3 different factors that are being used. So it's all factored out for us. This first factor here, 5x plus 3, if I set that equal to 0, that's going to end up giving me that x is equal to negative 3/5. So that's going to give us one of our zeros. The next one here of x squared plus 6, well, here's an example of having our imaginary solutions. If I subtract 6 from both sides, we get negative 6. And then I can't take the square root of a negative 6. That would give us an imaginary solution. So I am not going to be graphing that on my number line since it's not a real solution. And then the last one here is x minus 1. Now it's x minus 1 squared. So there's a multiplicity of 2 right there. And that would tell us that we would have a 0 at positive 1. So now what I'm going to go ahead and do is we're going to do our sign chart to see what this graph is going to ultimately look at, and where it's positive and where it's negative. So here I have 5x plus 3. If I pick a number that's going to be less than negative 3/5, so we could go ahead and say negative 2. 5 times a negative 2 is negative 10, plus 3, that's going to give us negative 7, so I would get a negative answer from that. Working on the next one, negative 2 squared would be positive 4. Positive 4 plus 6 would give us a positive answer. And the last one, minus 2, negative 2 subtract 1 is negative 3. Now negative 3 squared is going to give you a positive. These are zeros, right? And when I multiply a negative times a positive, I'm always going to end up with a negative in the overall interval right there. Going from negative 3/5 to positive 1, I'm going to pick a 0. 5 times 0 is 0 plus 3, that's going to give me a positive. 0 squared is 0 plus 6, well, that's going to give me a positive. 0 minus 1 is negative 1. Negative 1 squared gives us a positive. When you multiply 3 positives together, they will give you a positive. And then the last one being greater than 1, so I'm going to go ahead and pick 2. 5 times 2 is 10, plus 3 is 13, so that's positive. 2 squared is 4, plus 6 is going to end up giving us 10, so that's another positive. 2 minus 1 is positive 1. 1 squared is positive 1. So here I end up with 3 positives once again. So it's going to be a positive part from when x is greater than 1. When I think about my graph and what it's going to look like, I'm going to be starting out negative. It's going to go positive. Now it has to go back to the x-axis because that's one of our zeros, and then it's going to go to positive again. When we see that we have a multiplicity of an even amount, so x minus 1 squared, that's where that whole bouncing off of your x-axis is going to come into play. So if I wanted to say, okay, when is our function f of x going to be greater than 0? We would be greater than 0 from the interval of -3/5 to positive 1, as well as when x is greater than positive 1. When our function f of x is less than 0, we'd be looking at the values of x that are less than -3/5. All right, so what I'm going to have you then do is I want you to try and see if you can come up with this inequality on your own. See if you can create this. I will tell you that you can factor this one out. You do not need to use a calculator for it or a graphing calculator. It's a 3-term third-degree polynomial, but you can start by factoring out an x. And so what I'd like you to do is I'd like you to factor this out and to come up with the zeros. And then I'd like you to determine when is this polynomial going to be less than 0. And I'd like you to bring that problem with you to class. And like I said, we'll continue working with the rational inequalities as well once we cover out that. So if you have any questions, make sure you write them down. Otherwise, we'll see you soon.